Hey everyone, welcome back to another Prism Caribbean math tutorial video. I'm your tutor, Jordan Jaffa, and today we'll be continuing with algebra. And we will start off with addition and subtraction of algebraic terms. So, of course, when we deal with algebra terms, we're dealing with a lot of like terms. For example, let's say we have an apple. Let's say we have an apple and an apple, and some, right? So let's say you have one apple and someone gives you two apples, right? The total amount of apples you'll have now is 3 apples, right? But let's say someone gives you 2 apples and 3 oranges. The total amount of fruits you have is 5. However, you're only able to add them up together because of the collective term fruits. But you cannot add 2 apples and 3 oranges to give you 5 of another fruit or of the same fruits. 2 apples plus 5 oranges or 3 oranges will still give you 2 apples and 3 or 5 oranges, right? So that's the basic principle of adding and subtracting algebraic terms. So if we have 2x and 3x, because of the x's being the same, we place the x, and 2 plus 3 is 5. You can imagine this as the apples. 2 apples plus 3 apples gives you 5 apples. It's as simple as that. Yeah, but let's say now we have apples and oranges scenario. Let's say we have 4x plus 3y plus 2x plus 5y, right? Of course, in this case, we add the like terms. So we have the x and x, which will give us 4x plus 2x will give us 6x. And then we have the y's, which is 3y and 5y. Added together will give us 8y. And it's as simple as that. We add the like terms. We're just writing that here. Add the like terms. And it's as simple as that again. But let's go on to an application. And this is how many times in your past papers it will appear. Let's say we have 3x plus 12 over 7 minus 4x plus 4 over 5. And we will need to simplify this, right? So, in simplifying this, we have a common denominator, which of course will be 35 in this case, right? And we know 35 into 7 will give us 5, and we write down what we have to multiply in the bracket. Just to keep it simple, and we know 35 into 5 is 7, and we write back what we have to put in the bracket. So we continue by expansion. 15x, which will be 5 by 3x, plus 12 by 5 is 60, minus 28x, minus 28 of course, over the common denominator, which is 35, right? If you are not good at this point, just rewind the video and it will all settle. We take the like terms, so we know the denominator is 35, right? So we know we have 15x minus 28x, which of course will give us minus 13x, right? And then the other like term we have, which are the constants in this case, which will be 60 minus 28, which will give us 32. And that's our answer. 32 minus 13x over 35. Again, we have a common denominator between these two, which will be 35, right? And we simplify it from this point on by expansion and addition and subtraction, and we simplify our answer, right? And this is the basic gist of it, or the basic principle, I should say, of addition and subtraction in algebra, right? So now moving on to another term we have to know. This is regards to the multiplication and division of algebraic terms. So we have multiplication and division of the algebraic terms. Again, it follows the same principle. with regards to the multiplication and division, we multiply the like terms. Sorry, in this case, there's a bit of a difference. So with regards to multiplication, we can multiply xy. X by y will give us xy, right? And we'll get into the division now. So let's say we have something like x cubed over x, right? We know this will be by laws of indices, x cubed minus 1, because we have the same base. So we subtract the powers, so it will give us x squared, right? So just to recap now, just going over this topic. Let's say we have for null multiplication p squared x over r multiplied by r squared p over cube, right? That's a little of a tongue twister there, right? Of course, we can expand this out. We know we have two p's. We have a p and a p, and we have a q, right? And we multiply this by r squared, which will be r times r, and we know we have a p. And of course, we will have an r times 3 q's, and just like we knew before, we can simplify. So we have 1 q there. Let me write that here. We have 1 q there, 1 q. We have an r, and then we are left with 3 p's, an r, and 2 q's. And we know at this point we can't simplify any further. So we know 3 p's it will be p by p by p, which will be p cubed, and we have an r, so we can have the r here. And then we have 2 q's, which will be q by q, which will give us q squared. And that's it pretty much, right? Of course, note, when we have the same bases, right, we can add the powers, just like how I showed here. P by p by p give us p cubed. So yeah, I would like to do one more example with regards to this application of multiplication and division of algebraic terms. Let's say we have a question: a to the power 4 over b to the power 5 by c cubed, right, multiplied by b cubed c to the power 4 over a to the power 5, right? Of course, we can simplify this. So we know we have 5 b's, b by b by b by b, 1, 2, 3, 4, 5, and then we have 3 c's, 1, 2, 3. Then we have 4 a's, a, 3 b's, 4 c's, and then 5 a's, right? Now, of course, simplifying it, we have 4 a's here, so these can go out with the 4 a's here, right? And then we have 4 c's here and 3 c's here, so we can eliminate the 3 c's here and 3 c's here. And then we have 3 b's here and 5 b's here. And of course, we can eliminate that as well. And this will give us 1 over, we have an a here, of course, a, and 2 b's, which will be b squared, right? But let's do this another way. Let's say this is method 1, right? Now we have method 2, right? So now method 2 has to do with the indices method, right? So we know we have b cubed here and b to the power 5. We know this will be eliminated, and this here will be eliminated as well. Right, this here will be eliminated as well to give us a b squared, right? And of course we have c cubed here. That will be eliminated. That will be eliminated. And this will be c by itself. Because we have the same bases, we can carry the 3 to the top, which will give us 4 minus 3. And of course this a to the power 4 will be eliminated by a to the power 5, which will just give us a as well here. Right? Right. So I see I made an error here. There was a c on top here. So this is supposed to be c. Sorry about that. So we will have the c here, and we will have the b squared a. And of course, as we can tell, it's the same answer, right? And that's it pretty much for the multiplication and division and addition and subtraction of the algebraic terms, right? Now, recapping just a little bit on what we did earlier, right? In a previous video, I would like to just go over this topic one more time, right? So let me just select the black ink here. Let's say we have x plus 3 is equal to 9. We want to find x. Of course, many may go out of their way and say, hey, I can just put 6 over there, and you know, the equation will still hold. But let's see how to find it other ways. So we have x, and we know when we carry the 3 across, it'll be minus 3. So in this case, it will be 9 minus 3, and which we know x is equal to 6 in this case. But let's say we have things a little bit harder, and let's say 6x plus 3 is equal to 9. Right, just attaching a 6 to the x. So in this case, we'll have 6x, 9 minus 3, of which of course we know as 6. And x will be equal to 6 over 6, which is equal to 1. And that's it pretty much for that. But just to recap, if you know many people may be confused going onward from here, we have addition sign. And the opposite of addition will be subtraction. The opposite of subtraction will of course be addition. And then we have multiplication, and the opposite will be division. And of course the same goes vice versa with the opposite of division being multiplication. Let's see things go a bit harder and we incorporate multiplication and division. Right? Let's say we have an example. 2x over 8 is equal to 16 over 1. And we want to find x. So now this method is called the cross multiplication method, where we essentially want to write them out in one line. So we take the 8 and multiply by the 16 and put the 2x and multiply it by the 1. Sorry, have the 2x multiplied by 1. So 8 multiplied by 16 will be 128 is equal to 2x by 1, which is 2x. But let's just write this better for now. Let's say we have 2x is equal to 128. We know the 2 is related by a multiplication with regards to the x. So we know if we want to solve for the x, we have to remove that 2. And in order to do that, we have to divide both sides by 2. Right? So this will just leave us with x is equal to 128 divided by 2, which will be 64. And that's it with regards to that. Right? And just to go over one more example with regards to this, because I don't want to make this video too long. Let's say we have a question like 4 into 9x minus 7 is equal to 8. Right? Now, just for like introductory purposes, I'm going to go over the expansion rule. Right? Of course, 4 into 9x will be 36x, and 4 into minus 7 will be minus 28, and then we have it equal to 8. And then we can use our basic principle knowledge of transposition, and we have 28 plus 8, right? Right. We have 28 plus 8. Right, that should be better then. And then we will have 36 is equal to 36. And we know x is equal to 36 over 36. And of course, x is equal to 1. We know the x and the 36 were related by multiplication. And we know carrying across the minus 28, we will get positive 28. So we will have 36, x is equal to 36. And of course, because this is related by a multiplication, we divide it when we carry it across to the other side. So we can say 36x over 36. Cancel, 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 cancel. So we'll have x is equal to 1. Right? We could have done this another way as well. Let's say this is method 1. And this here is method 2. Let's say we have the 4 into 9x minus 7 equal 8. Now many will see from this pattern on, we can easily divide both sides by 4, right? And of course equate the equation, and let's see how it goes from there. So we know 4 divided by 4 will give us 1, and 8 divided by 4 will give us 2. So we will have 9x minus 7 is equal to 2. And just going across with the same principle, the transposition, we'll have 9x is equal to 2 plus 7, which is equal to 9. And of course, moving on with the same order, we will have x is equal to 1. Just like how we have it on both sides. And that's it pretty much with this concept. So moving on from here now, the next algebra topic, we'll go over the rules of indices and maybe touch on inequalities in math as well. But if you want, of course, just go over the video, play it back slowly, and grasp the basic concepts, and always remember, practice makes perfect. I am your tutor, Jordan Jaffa, and this has been a wonderful session for Prism Caribbean Math, and I look forward to having you in my next video, which will be on algebra, of course. Thank you, and I look forward to seeing you in the next video.